malaria, dengue, chikungunya, and now Zika. These are all mosquito-borne illnesses that have plagued our planet and made headlines across the globe while causing public health crises wherever they spread. In Ontario, by virtue of our tough climate and strong public health systems, we have been spared the devastating effects of these illnesses. However, we still have to contend with another mosquito-borne illness, West Nile virus. Although the effects of this virus are fairly mild in humans and case counts are generally low, the sporadic nature of this disease makes it difficult for public health systems to determine when and where to best intervene in order to prevent illness and to optimize the cost to the system. However, at the root of this issue is a simple question: where and when do humans get bitten by positive mosquitoes? In Ontario, every year, public health units undertake collection and testing of mosquitoes for West Nile virus. Every year, these same public health units report cases of West Nile virus to Public Health Ontario. So how can we use these two sources of data in order to be able to predict when and where human cases will occur? Oftentimes, any given infectious disease will localize in space and in time. This is referred to as a cluster. In my thesis, I decided to try to see if mosquito-positive clusters could predict human cases. I found that in high-incidence years, human case clusters occurred in Toronto, Halton, and Windsor-Essex County. Mosquito clusters also happened in these same areas, however 2 to 3 weeks in advance. I also found smaller clusters occurred 1 month in advance of these human clusters. But in years with low incidence, these smaller clusters did not occur at all, showing us that these analyses can differentiate between years of high and low West Nile virus incidence. By using a combination of mosquito data and freely available cluster software, public health units may be able to determine whether a given season of West Nile virus may or may not be high risk, and where and when human cases are likely to occur. By strengthening our understanding of West Nile virus in Ontario, we can strengthen our understanding of when outbreaks may occur for this disease and other mosquito-borne illnesses that may enter our territory through public, trade, and travel, or through range expansion through climate change. Thank you. Any questions? Okay, good question. So far, what I've been doing, I haven't done an actual metric to directly correlate the two. Oh, well, the slide is gone. But based on just the map and where we can see the two clusters happening, they coincide. And also the detection software I use outputs kind of like a date for the clusters. So based on that, I can figure out that based on the time and the location, we can see that the mosquito clusters are happening 2 to 3 weeks or 1 month in advance of the human clusters in the same area. But yeah, the next step, I'm planning on doing a kappa statistic to actually correlate the two. But yeah. Anything else? No? Thank you.